Yes, dear students, welcome to all of you in practical period of physics. So in this period, we are going to find the focal length of the given convex lens. About lenses, you have studied in theory, and you know what is a lens and what are the types of lenses. We have studied two types of lenses, convex lens and concave lens. So here we are going to find the focal length of convex lens. And for this, first of all, we should know what is the aim of the experiment, apparatus required or material required, theory, then of, right? So first of all, the aim of the experiment, you have to write down in the notebook that to determine the focal length of the given convex lens by obtaining the image of a distant object. For this, we have to consider distant object. You will see here in the experiment that the distance object which has been taken is a window of the physics lab here. So the material required here is optical bench. Optical bench. Optical means light. So the bench, optical bench. You will see what is optical bench. Lens stand to hold the lens. Screen. It is a screen of paper, circular screen with stand. The given convex lens and a distant object. So what is the theory here? So what is the lens? Here we are going to study what is the lens and what are the terms related to lens. So here convex lens, it is also known as double convex lens because it has two curved surfaces. So double convex lens is a piece of optical medium. It can be of this plastic also, transparent plastic. So therefore optical medium bounded by two convex or curved surfaces on either side. It has two spherical surfaces and has two centers of curvatures and two foci also. This you have been taught in theory. So, if the object is placed on any one side of the lens, the image will be formed on the opposite side, on the other side. Why? Because, it forms a real image. So, it is formed on the other side of the lens. But for an object placed between optical center and principal focus, the case is different here. So here the image form is virtual and it is on the same side of the object, therefore same side of the lens. Therefore it cannot be taken on the screen. So now first term is here optical center. It is the center of the refracting surface of the convex lens or concave lens. So the next term which is related to lens is principal focus. So what is principal focus? Again we are repeating here because I'm saying repeating because you have been taught in theory. So it is the point on the principal axis where rays of light incident parallel to the principal axis after refraction from the lens either actually converge. Converge means actually meet at a point. That happens in case of convex lens. Here you can see rays of light parallel to the principal axis after refraction means after passing through the lens meeting at a point on principal axis. So this point on the principal axis is known as focus, right? And in case of concave lens, these appear to be coming from a point after refraction. Okay. So now focal length. Here we have to find the focal length. So it is important. So focal length, it is a distance between optical center O. It is the center of the lens from where the distances are measured. Distance of the object, distance of the image, and distance of focus is measured. So it is the distance between optical center and focus of the lens. Okay, it is denoted by f, small f. Focus is represented by capital F and focal length is represented by small f. So when an object is at infinity in front of the convex lens, its image is formed at the focus of the lens. And distant object can be considered as an object at infinity and its image will be formed at the focus of the lens. To get the image here on the focus, we use screen. Okay, so image is formed on the screen and when clear image is formed, So that means that image is at the focus of the lens. So the image which is from the screen, we know it is real, inverted, and of smaller size, very small size. So for a parallel beam of light coming from distant object, a real, inverted, and very small size image is formed at the focus of the lens. So since image formed by the lens is real, so it can be obtained on the screen. So thus we can measure the focal length of the lens by obtaining a real image of the distant object at the focus. Focus means screen. Image will be when image is formed clearly on the screen, so that means that is focus. And this length will give us here, this distance will give us focal length of the lens, right? So now these two diagrams you have to draw in your notebook. Now we are going to perform the experiment, and you have to note down the readings, and you have to see how experiment is being performed.
Yes, now after writing aim of the experiment and then material required and then principle or theory for the experiment, and now we are going to find out the focal length of the given convex lens. Given convex lens. So here you can see optical bench. On optical bench, convex lens is there. So this is convex lens here, which is also known as converging lens. And this is the screen on which we shall be getting image. Screen के ऊपर हम image लेंगे and convex lens है. This is convex lens, converging lens. And here this line, it is showing this optical center. From this point, distance will be measured. So same way here, this is the point, this is the mark, this is the line. From here, the distance will be measured between lens and the screen. Now let's start. So here we are going to take the image of the window, or you can see trees. You can see the trees and plants. So we shall be getting inverted image. Inverted means real image of the plants and screen and window on the screen. Right. So now let's start. So first, this screen is fixed at. Yes, it is fixed at what number? It is 55. It is fixed at 55. Yes, screen is at 55. Now, there is no image. There is no image on the screen. So now I am going to shift the lens towards the screen. So now you can see what happens. I am shifting the lens, and you will see the change. It is being shifted here. You can see. Now image is coming on the lens. You can see clear image we have to get on the screen. And it's not clear. Now we have to move it back. Yes, it is a clear image. Now it is not clear when it is moved back. Now at this point, clear image is there. It is inverted also. You can see trees are upside down here. Because we know that a real image is always inverted. Now we have to find out focal length of the convex lens. For this, we have to read the position of lens here. You can see lens is at 45. And here the screen is at 55. So 55 minus 45, what do we get? 10. So the focal length of this lens, convex lens, is 10 centimeter. So now we have to take one more reading. For one more reading, I am changing the position of screen, and it is at at this point. And this is how much? 56, 57, 58, 59. It is at 59 centimeter. Now, you can see no image is formed, and lens is at the same position, 45. Now we have to move the lens. So I am moving the lens towards the screen, and you can see image is formed. Clear image is formed. It is distinct. Okay, you can see clearly. So now we have to find out the focal length. So for this, we read the distance between these 2 points. This is 59, and here it is coming how much? 50. Here it is 46, 47, 48, 49. 49.2. 49.2. And when we subtract, what do we get here? 10 centimeter in first case, 10.2 centimeter in second case. We can take one more reading. For one more reading, we have to change the position of screen or lens again. Either out of these two, any one can be changed. So any one can be fixed. So yes, it is fixed at 70. So screen is fixed at 70, and there is no image. So now I am moving lens towards screen. Yes, it is moving. Now you can see images form. Yes, we have to get the clear image. So for clear image, it's not clear, and now it is blurred. Move it back. तो थोड़ा पीछे ले जाएंगे, and yes, now it is clear. You can see clear image. Now if I asked a student to stand in front of the lens, so you can see again inverted image is there. Head is here, you can see down, and head is down. Okay, so upside down. So inverted image is formed. So inverted image of the student is formed on the screen, right? So this is a clear image. This means it is inverted and real. So now find the focal length. Here it is 70, and it is 60. It is 60.2. 60.2. So we subtract and get 10.2 again. So 10.2 centimeter. So we have got three values: 10 centimeter, 10.2 centimeter, and 10.2 centimeter. So we have to find the mean. Now let's find the mean, and after that we find the focal length of the given convex lens.
Now we have got the focal length. So now we have taken the three readings. Now we have to find out the mean value. What is the mean of the three readings? Means we have to find the final focal length of the lens. So here position of the screen, you have to make this observation table in your notebook. Remember this point. So here are observations and then calculations. The position of the screen, it is at 55 centimeter. Position of the convex lens, it was at 45. So we get 10 centimeter. Same way, second reading was 59 centimeter, 49.2 position of the lens, we get 10.2. And then in third case, position of the screen was 70 centimeter, position of the convex lens 60.2 centimeter, and we get focal length 10.2. Now calculations, mean focal length, sum of these three values divided by 3, we get 10.1. So our result is here, the focal length of the given convex lens is 10.1 centimeter, right? So this way we can find the focal length of the given convex lens. So nowadays, practical based questions are also being asked in exams. So practicals are very, very important, and practical knowledge in science, it helps us to progress. Right now, precautions. So what precautions we have to take while doing the experiment? So you have to write these precautions also in your notebook. To get a well illuminated and distinct image, distinct means clear image of the distant object, the object should be well illuminated. It should be clearly visible. Convex lens should always be placed near an open window. Why? Because light could fall on the lens. Okay. So convex lens should be properly clean. It should not have dust on it. Then image will not be clear. There should not be any hurdle between the rays of light from the object, right, and the lens. So if there is any hurdle, then image of the object which we have to which we are considering will not be clear. The screen and the convex lens stand should be parallel to the measuring scale. The lens holder along with the lens should be perpendicular to the measuring scale. So these are the some precautions which you have to follow. So I'm sure that you must have enjoyed, and when school reopens, you can do this experiment on your own. Thank you.